Sorry, I did not push the button. We have some changes on this session because Anna, which was going to do the second presentation, Space Syntax as an agent-based system, that logo framework proposal, is not possible to come because she was robbed at the airport show. But she will present another day. She will still coming to the Congress, but it's not possible to be now. So we will present two papers, two communications. This session has a common denominator. All the three papers focus on the networks and urban movement. They also use different technologies to do spatial analysis of these networks and this urban movement. And they do that in specific environments, okay? One of them in Cairo, historic Cairo, another one in Belgrade, and the third one, which is Anna, which is not coming, was mainly, as far as I understood, more about technology, how to experiment some technology using space-based agents in the space syntax. So the three communications will be, the two communications, sorry, will be visualizing urban experience, artificial intelligence and computer vision framework for historic commercial streets in Cairo by Professor Nabil, which is in here. And the second one will be analyzing the network effects of vertically layered urban structures on pedestrian movement by Nikola, which did not arrive yet, but we hope that until the end of the first communication will be in here present. So I will call Professor Nabil for the first presentation. Thank you.
Good afternoon, everyone. It's a pleasure being here, and this is my first time in Porto and Portugal. And I'm going to present the Visualizing Urban Experience AI and Computer Vision Framework for Historic Commercial Streets in Egypt. And I am an associate professor from the American University in Cairo. Well, the research aims actually to introduce an initial framework. It's not a final one, it's just an experimental one that integrates space syntax, computer vision, and empirical field observations, building on Peter Busselman's work on urban perception and movement to analyze pedestrian visual experience in historic commercial streets, perceived duration, emphasizing visual complexity, spatial richness, and vocability. And actually, yesterday we had nice experience walking through a historical part in the city, and as a group, each one of us, were looking at certain point, standing at a certain point, take a picture at specific landmarks. So it was a nice experience. What if we can quantify this experience? So this is exactly what I'm going to try to present here, not about the experience of the Porto, of course, but about two cities close to my heart, Alexandria, which is my home city, and Cairo. The framework is simple. What if we can, or we need to understand the visual experience within commercial streets? What should we do? We proposed first point, which is understanding the spatial analysis using space syntax, try to understand the urban network there in order to find where are spaces that people might tend to go. And then we have used quantifying or try to quantify the urban scene content using computer vision. And the third point, which is the time and duration, and try to understand what actually we have observed from these points. All these together could give you a visualizing urban visual experience in historical commercial streets. And the quantifying urban scene using computer vision, it was based on a previous research that we have done in-house So we have created our own software, is trying to obtain from videos or single images. As you can see from the middle, this was a very tiny software. Trying to have like a whole video and extracting frames, specific frames, and these frames were using YOLO. At that time, it was version 8, which to do segmentation, meaning segmentation is like having here understanding the boundaries of each element of the scene, and then pushing things forward or pushing things more is trying to extract the percentages from each scene of the building, the roads, the people, the greenery, the sky. This issue is not new. It's been already done previously, but integrating this within this framework, we assume that might be a new approach. And this is the sequence of the software itself is having the input of video or image or even GPS geospatial location points, and then try to understand the image and its location, try to have some sort of a processing and doing a segmentation using YOLO modeling. And segmentation, of course, classifications, try to find the areas and counting objects and focus. Because when you're going to have your mobile phone and just clicking on a place, the center part, or this is the focus of what you are interested in. And this is really, we are capturing within our software. The two main case studies here, one of them is in Cairo, and it's near to or part of Cairo. It's called Wakalat al-Balah, and located near to the River Nile, and it's well known as a marketplace offering a variety of goods, particularly clothes and textiles. Some of them are new, some of them are secondhand. So you can find middle low classes that are always, shopping there. And the second case, it's within Alexandria, and within the oldest part of the city. Actually, it's called Zanat al-Sittat. And you can see that it's an Arabic name, which is, when you're going to translate it, called Women's Alley, and it's a historical market in Manshaya district in Alexandria. And again, it's known for goods and specifically clothes and textiles for women and all related issues. But don't ask me how I get there and take photos, because it's open, not just for women, for everyone. The first step is, our initiating step is analyzing the street network for walking route selection. So we have done a normalized integration, and we have used a normalized in order to compare between different scales and different locations. And we have taken the integration and choices and relied more on choices. And using like 200 meters and 400 meters for a pedestrian selection part, in addition to understand the global one, which is the RN. And here you can find like relationship between the means and the standard deviation and minimum maximum. Let's focus on the mean. You're going to find that Alexandria, most probably it's having higher means for Cairo at certain point. And according, or besides using space syntax, we have used some sort of field observation nodes, trying to understand the spaces and trying to find different layers when we're moving, because you're going to find, we found that there are almost 3 boundaries or 3 layers. The first one, which is the walking path itself, and of course the first visual boundary is all the goods, all the clothes that are on both sides. The second visual boundary is the commercial places itself, and the third boundary, which is the rest of the building and the sky. So most probably you're going to focus on the first and second boundary. The third and the fourth boundary is a little bit, you cannot just having it's not within the scope of visual focus when you're going to move or take photos or take images. And we have some sort of like a walking route through both cases. This is for the Zanat al-Sittat in Alexandria, and as you can see, it's the duration of walking is almost around. We've fixed the duration of walking for 15 minutes to see how much we're going to see, and plus what actually we're going to see there, and the feelings of what you're going to see, whether it's something interests you, you get bored, you get interest, and where. And this is the part which we think that is interesting or could be compared to other cases, which is quantifying. I know quantifying issues is a dangerous point because you are missing all the emotions or related cultural points. However, quantifying what you see in the scene itself, it might be useful if you're going to compare this or 3, 4, or hundreds of commercial streets. So here you can see that buildings through the black part is occupying the most issues in the scene of Alexandria, while the sky is less and the greenery is the least. Comparing this or trying to understand this in a heat map, you can see that buildings are really occupying all or most of the scenes through all the frames captured there. With the skies, the second issue, and the trees or greenery are the third one. And you can have some sort of understanding the scenes just from this heat map. So this is for Alexandria. For Cairo, Wukalat al-Balah, we have just walked almost the same duration, but it seems longer, but it's having, I mean, feeling longer, but having the same distances. And you can see these are the images captured from the walkthrough itself. And comparing here, what you can see, the greenery is much more occupying more of the scene, more than the buildings, and you can feel that the spaces are a little bit different than the Alexandrian one. So, and from this heat map, you can see, yes, the buildings are still dominating the scene, but the greenery and the trees are there as well, and even competing at certain frames that even more than the building. And you can see more of the sky and, of course, the road and traffic signs and the persons and cars, you can see them there as well. So comparison of pedestrians versus vehicle space in Cairo and Alexandria, you can see that most of the Alexandria part are dealing with vehicles more than the pedestrian issues. On the other side, comparing the urban scene components between Cairo and Alexandria, you can see that Cairo is exceeding from the tree vegetations, but less in the building, while Alexandria is exceeding in the building and the car dominant part, and even on other factors as well. All right. So as a conclusion, spatial configuration, urban livability, the spatial setup significantly impact visual experience. Pedestrian behavior, I put under this like thousands of lines because we didn't capture the pedestrian behavior. We intended to, but in the future, we need to have more layers, more issues in order to capture the behavior action of the pedestrians there. And the commercial vitality, of course. And this framework could help in comparative analysis of two streets, as this is the case right now in this paper, but it could help in cross cultures, multiple cases. It could be like hundreds of commercial streets along the globe, trying to compare them and try to quantify the data from there. So we have done here the Wukalat al-Balah in Cairo, which is having like a balanced elements of the sky, visibility, and vegetation compared to the other issues. And even when you're going to walk there, you might feel more comfort and reduce of the fatigue, although it's the same distance like the Alexandrian one, but in the Alexandria, then it's much more dense, immersive. It's a traditional style configuration, provides authenticity, but limited modern walkability. About the computer vision and urban analysis, we have used YOLO model, which is you see only once, and with Space Syntax offering a scalable objective analysis of visual complexity and spatial patterns. Space Syntax was just initially, if you don't know the place, you might use it at first in order to understand how people might move there or potentially. But of course, you need to have a field investigation to make sure that it's really reflecting the reality. And we have used, of course, the computer vision to trying to quantify the space there in order to understand or to inform the decision makers whether the space might need more vegetation, might need less, whether it's dense or not, quantifiable issues. And of course, the practical contribution for this, we can combine quantitative matrices or metrics and qualitative insights, which we haven't done this in this paper, but we wish in the next scenario to include them. And actually, I've done it in one of our research dealing with noise and sound. And of course, we are differentiating between sound in general and noise in particular, and adding this level of the noise and sound, plus what you see, plus the spatial configuration, you might have, like, I'm not saying comprehensive analysis of the site, but at least you understand the site much more. And of course, you can add layers of not just noise, you can add odor, you can add a lot of other layers. So to provide a robust toolkit for researchers to understand urban spaces better. And by doing this, we can support strategies for improving urban comfort, economic vitality, and heritage preservation. And of course, this is an initial start. A lot of limitations about these methods. Yes, we acknowledge it, and we are working on how to enhance it in the future. Like the first one, which is the temporal variation. More analysis across different times. We need to understand that walking daytime versus nighttime, under raining like yesterday or not. So it's completely different. And you can have the duration and the experience of the space is completely different, adding to it seasonal changes. And of course, future research could explore how temporal shifts affect pedestrian behavior and commercial activity, because commercial activity might be affected by the season, might be affected by a lot of issues. And we need to include or inject multisensory analysis. The current framework focuses solely on visual elements, but other elements could be included, like I've said, like the noise, temperature, and smell, and odor, and deepen insight into urban livability. And we can start to do something related to cross-cultural validation issues, which is using the framework, could be tested across different cultural settings to understand whether it works or need more enhancement. And the comparative studies could reveal universal principles, which we need to investigate in commercial streets, and the culturally specific adaptations for historical commercial ones. And related to technology, of course, right now, I mean, this paper was, I've started a year ago. I think that 2 different versions of YOLO has been established already there. And the system and AI segmentation, all of these issues are rapidly developed. So I think this software or this approach could be developed more, including more lighting conditions, shadows. And this is the limitation of computer vision, of course. When you're going to take an image in different light conditions or shadows and occlusions in dense urban areas, you might find yourself having different outcomes. And misclassification of unique Middle Eastern architecture elements, we've tried to develop or having our own AI model to understand the architectural elements in Alexandria and Cairo, because the generic one is not adapted to a specific culture. It's too general. When I'm going to write anything related to Islamic architecture, it's just leading to a specific era in area in Iran or Pakistan. It doesn't include any other specific locations. So that's why we need to train your own model if you'd like to add things could detect the architectural elements. And of course, it's limited to visual elements, missing dynamic aspects like temporary market displays or seasonal street modifications. So in order to enhance it, we need to consider all of these technological aspects or constraints, and of course, develop the methodology to adapt to different places, different cultures. And I think this was the last slide. Thank you very much.
Okay. Thank you. I hope that you hear me. Good afternoon. Hello, everyone. I'm Nikola Mitrović, PhD candidate engineer research assistant on the University of Belgrade Faculty of Architecture. And I worked on this paper with my supervisor, Professor Dr. Aleksandra Djukić, from the main faculty also. So the main topic is considering analyzing these network effects on the vertically layered urban structure, especially pedestrian hub, on pedestrian movement, on example, a case study of Mostar Interchange in Belgrade, Serbia. So the structure of the research is mainly focused on theoretically considering that interchange and pedestrian hub for spatial examinations from the modernist principles from in history to today, as that comparison between behavior and network. Methods are mainly combined with some form of walking interview, like social structure, social method from social sciences, and these formal methods like spatial analysis from space syntax and behavioral observation like space syntax observation techniques, and it implemented on study area Mostar Interchange in Belgrade. So when we are talking about these modernist principles that occurred today, that we have this layer structure that mainly focused on that public space to be layered and diversified between pedestrians and vehicles. So we have these public spaces that are on layers, and also implemented these principles on some transport hubs. And also on other side, in some methodological aspect of research, we have that network size that can be implemented in spatial analysis. And why it is important? Because that mobility function is also like pedestrian usage is ecology type of usage in a space, and it's really popular about these new mobility trends and aspects. And also from the cultural aspect of the topic, we have forming these momentary communities about topic from the cultural studies, because we are not talking about that people are living on some area that are strictly on that space. They are just passing through these spaces. And also in cultural studies, we have that term like liminal spaces for that. And what is the aim and in order of this research analysis is to make the reconfiguration of existing paths in these transport hubs, and to make the better usage of space, and to satisfy all of needs that passers have in these spaces. From the theoretical type, we can say that these new initiatives about that pedestrian-oriented space and streets, that is really changing the paradigm of focusing on space, comparing to the modernist principles, where that was separated vehicles and pedestrian spaces. But also we can see these examples in history that some medieval planners also made these pedestrian space. So maybe we are talking about that backing to our roots and some human necessaries. And also on this methodological aspect, we can talk about that implementing space syntax of a multi-level, and implementing that network science. And also we have some examples about that extended axial lines when we have that incorporating change height, and also some isovis properties and parameters in like MTR stations. About the methodology, so walking interview, it's like experimental method, because it's between quantitative and qualitative data, because we are talking about that routes and conversations. While we are walking through the space as a researcher, we are talking with users, and we are collecting that data. So we are collecting their routes and their data, what they are saying while walking through that space. So it's a better that sedentary interviews, because when people have these data from the space where are in space. So this is also face-to-face face-to-face interview, and there was about 30 passers-by in this case study of Mostar Interchange. And they also asked about, after these questions, they asked to draw the route of their movement through the interchange. So it was analyzed how people are moving through this space. About the formal methods, it was based mainly on the gathering data by gate count and analysis like axial integration connectivity in diffmap X. In behavioral observations, it was mainly focused on tracking and mapping using video and these frameworks like user category, spatial usage distribution, and gate counts. And why is that Mostar Interchange is study area specific? Because we are talking about that important traffic point in an old part of the Belgrade. And under that highway, we have that pedestrian hub, which is important to connect two parts of the city. And also it's like a model hub, because we have these bus and tram stations, and we have these radical changes in environment of that hub. So we see here the Belgrade plan, and this one is the highway, which was from the socialist period, now is transformed to as city boulevard, and this area is that important Mostar Interchange hub. So this is from the sky view, and we can see here that is like a layered structure about the vehicles, but also for pedestrians under these areas. So here we can see these elements. And this is from the usage perspective. We have seen these not just configurational problems, but also environmental problems about that lighting and sound effects of that so many vehicles, and also usage aspects like safety aspects of vandalism in space, and so many aspects. But focused here wasn't just on a pedestrian flow map. So from the socialist period, here is like a historiography data where we can see this highway that is constructed for the socialist period, and all of these nodes as interchanges. And this one, that's Mostar Interchange. And here are the photos of how the environment of that interchange is radically changing, because we have all of these new developments and new buildings, and because of these new properties, the pedestrian logic of space is changing. So pedestrians need more space because we have all of these riverfront development. And the results about the walking interview, we can say that there are not just the routes for the transport. We have all these routes like work routes, study routes, shopping routes, and we can say that respondents didn't aware importance of these interchanges as architectural space, planned space or work. And also we can say that about these drawings of the respondents, that people have a problem in orientation in space, because it's symmetrically, but they are confused about which side of the interchange are using and which station need to go, because all of these staircases and these narrow paths. About the spatial analysis, we can say that about an axial analysis integration, we can see this path as the mostly integrated with value of 4.7 and the radius 2, because we had these two turns mainly when we are walking through this space. And about the visibility analysis, we can see that VGA connectivity is mainly focused on these like intersection dots for the pedestrians, but it also corresponds to gate counts we will see later, but not in mainly in these usage aspects. And about that pedestrian flows, we can say that here we can see flow movement and here collective movement, because in this area we can see that all pedestrians are collectively moving to this area and changing the position. And also here we can see this site map and the position of the interchange in the environment. All of these areas are under construction. That's the big development of Riverfront. And here on the other side is that existing old structure. So we can see these pedestrian paths. And also this is the video mapping from the different positions through the different times. So during the workday and the weekend, it was video mapped, and after that on the video mapped, it was implemented gate counts, and it later it used for that analysis for the levels. Also, we can see from these video and photos that about the user category that are not just pedestrians, but also like bicycle and scooters drivers, and about that spatial usage, spatial usage distribution, that people are mainly affected by the configuration of these paths and the architecture of that space, about the level, height level, and about that form of the paths with that railway, and about the architecture and usage of a color. But it's mainly looks like abandoned because that was not any intervention of since the socialist period. And we have see these gate counts on the map, and we can see that the most affected part is that which is connected with visibility studies, but also we can see all of these values about that flow and integrated movement. And also we can see about that flow and collective movement that the number is about 500 passers by, but also it's more in detail analyzed comparing to level and all other variables. And we have see here variables about level variation, entrances, and vertical transitions. And we can see that on this level that we have seen, we have about 1,040 users, but on other levels are the smaller values. About the entrances, we can see that mainly, I don't know, maybe about 95% of users are affected about the entrances. So the movement is connected with entrances, and just 100 is not. And about the vertical transition, we can see that about 1,000 users are using that vertical transition, and about 600 not, just moving through the space. So we can make the correlates about that level entrances and vertical transition is a huge dependencies, and that there is a need for transformation of this space because of these geometry and configuration, and to adapt to more human environment and these new spaces in a area. And also we can say that because of these different users, we can say that area became the recreational area because of the activation of riverfront. And these in these aspects of methodology, there is lacking some quantitative data, like possibilities of implementing these raster vector detection, like automated process of counting in these video mapping, and also implementing more that cultural aspects of theory about that momentary communities. And the future research, we can talk about that integrated approach about all of these aspects between quantitative and qualitative approaches, especially about that metric analysis and vocability, and also implementing that network science metric, because all of these layer structures are good potential for implementing these aspects. And that's it. Thank you for your attention.
I now call Nabil also to come here. Unfortunately, we don't have Anna. This will be interesting to complement, because we have two presentations that are dealing with very different spaces, okay? But both are dealing with networks, both are dealing with people, how people live, and it was interesting to see how agent-based will be using this space, and what tools could be used. I have here some questions before I pass it to the audience. Professor already took me some questions, because when you put the limitations, I have some questions. But however, limitations are also opportunities, okay, to develop. It was very interesting also to see how some work and some presentations of the first session could complement in here. For instance, what Nuno showed about slope, and so other factors that can also be included, of course. What I have here is more technical, probably, or methodological questions. One is if it was interesting to involve sociology in here, okay? Because I would like to understand of those scales were produced, how is important the relation between sky and buildings, and I'll say that is better than that could be cultural, okay? Sociology also could have some role in here, I don't know, okay? Another one is about this software. Does it use artificial intelligence to analyze the images? A kind like remote sensing in GIS? More or less, okay. And so I'll pass to Nikola. Now I understand after seeing the images, which make a great impact, because I read the abstract. Now I understand why you put non-places in the abstract. Okay, makes sense. But I would like to know, you have complemented with several techniques, several tools. Okay, I think interesting. One of them makes me wonder, do you work there in Serbia? Because we had a problem. We tried to do work here in Porto with video mapping, and we are stuck with the rules. We cannot do it, okay? It was not allowed because of the protection of that and so on. So do you have the problems or not? And other questions is if you used in your video mapping, then a software for tracking, okay? Or we had another methodology to do that. And of course, at the end, if this, I understood, you said it, will be a methodology that could be applied in other places and so on, complemented with several methods, interviews and so. But in this specific case, you'll also help urban design at the place. Some of this information will be passed to the new project. So, hopefully,
yeah. Well, first of all, thank you very much, and nice, interesting questions. I would like to start with, of course, there's psychological effects of how you, I mean, if you're going to walk in a place that you don't see greenery or the sky for a certain amount of time, you might just feel differently if that space having its own greenery and a certain amount of sky. And sky here is just might be rainy, cloudy sky or might not. So all of these variations could affect how the people behave, their mood in navigating that space, and reflects on their interest and the duration of time that they want to walk through that street, or just let's move it quickly. So all of these issues could really affect the perception and affect their journey or their through that space. We wish that we can have some sort of a system that comprehensively could attract or extract all of these data and understand it in one point. It's so difficult because are you dealing with one person or homogeneous group of people or heterogeneous group of people? Are you dealing with tourist intention? Yesterday, I was just full to everything I'm passing. My friends from Porto just pass. I mean, they know the place. So even the behavior of an individuality on that space different. So of course, psychological issues, sociological issues, they need to be implemented one way or another. That's why in the limitations, which you've said it's an opportunity, we can add in the future different layers, and all of these layers at a certain point could give us at least a clue that this place is working well for the people and to whom. I mean, if we can categorize the people because people is too general issue. We need to understand we are dealing with tourists or we are dealing with locals, we are dealing with whom we are just intending to make the space better. This is the first one. The second one about the technical question. Yes. The technical question, we are using artificial intelligence and machine learning in trying to understand the object detection, detects people, and they segment them, meaning that giving like a mask layer, and this layer you can have the area compared to the area of the entire image, so you can have like a quantification of the content of the image itself. So this is like in a nutshell what is doing there. So did I answer your questions?
Yes.
Thank you very much.
Thank you.
Okay, thank you so much for your observations and for your questions. First one about that problem of data about the video mapping. I had any problem with that because I don't know, anyone is not affected by that, and about the rules we don't have any kind of that. And I was also a little bit shocked when I find in literature about that aspect that you don't it not allowed to video in every space, like especially like this one. But also here I don't recorded any face. It was from the distance, so I just was in a corner on one of these points on the staircases and just stayed there and video recorded. So, and anyone just asked me, everyone thought maybe I just photo collecting or something like that, and anyone is haven't any idea what I'm doing there. So that was about that video mapping. And also I in this paper I just used that like manually counting from the video, but for the future research I will maybe consider all of these aspects about that professor yesterday talked about on a workshop. And about the third question about the urban design, I can say that maybe I have not mentioned on the start of the presentation that this part of my PhD thesis project, and I am making comparison between these spaces like transition liminal spaces with neighborhood spaces where we have like passages and similar spaces where people are just passing by through the space, and I am comparing that the quality of space between these spaces. So this is just the part of the bigger research. So in the future, I will making these bases about these aspects. And what about second question? Okay.
I'll go with two recommendations, one for each, because you said, first of all, you said in the end that you had the issues with, you know, light conditions and everything and shadows, and I totally agree with you on that. It's quite tricky. So one way you could not avoid, let's say, you know, go a bit further, is that with segmentation models, any segmentation model gives you area of similarity, right? Or whatever object detection or detection algorithm you use. Nowadays, we can use vision-based LLMs to do descriptions of the area, so you can avoid the problem, let's say the shadow, because you can say that I don't really care about whether the shadow is different. Give me description of like language-based, like text-based description of the elements. And you can also sub-segment, like, because probably LLMs and video LLMs are using 16 by 16 kind of segmentation models, right? Equally distant quantization. Then you can also probably avoid the problem with the changing time of the day, etc., because it's the same object in light conditions. So you can say, okay, I don't really care if it's day or night or midday, and there is like too much shadow. If you see, I don't know what, you know, kind of something there, describe it to me. Do you see it? Yes or no, or whatever. So you can avoid that. And for you, because we, one of my my researchers, she's having similar issues, and I'm totally with you on all this kind of ethics. I'm sorry, it's been recorded, but whatever. You know, ethics, all these kind of ethics committees. Well, it's been recorded, so yeah, probably yeah, we've got similar issues. So I'll give you the answer. I'm not going to say what we do exactly, but there is a way. If you use, let's say, if you want to do it automatically, at some point you'll end up with, probably, I would say, your pipeline is going to be a depth estimation system, a depth estimation. Then you're probably going to use some sort of a ResNet to match similar people that walk, because you might lose them, right? So you need like a higher dimensional identification of the shape that you're going to cut from the depth estimation. If you do all that in a local laptop, so like a Mac that has like this new kind of GPU, CPU situation, the battery can hold like running 3 or 4 models in the same pipeline for an hour and a half. So you can claim that, well, no, not claim, sorry. You have to do it, let's say, or claim that you did it, that you filter everything that is identifiable, and then everything goes into some sort of latent space. So you don't keep the original identification of the actual person. You got a depth estimation plus the segmentation model plus a ResNet, let's say, identification of the intrinsic characteristics of that person's, let's say, outfit. So you can match him or her throughout the course with interruptions and 2 people bound, you know, being in the same bounding box. So you could avoid having that issue. Maybe doing it all locally with the camera for 1.5 hours every day, let's say, or whatever, every charge. And that usually is a bit more understandable, but I understand the problems. And maybe, well, idea number 2 is probably I would go and recheck when you call something VGA connectivity. I'm not sure it's exactly what you think it is. As a comment, go check it. It's not VGA connect. It's probably isobit size. It's a local measure. VGA is pretty much we use it when we want to do integration and more global, because it's more of the isobit size that you were comparing there.
Thank you. I mean,
Thank you. Thank you for your observations. Yeah, and I agree with everything you said. So just thank you.
More questions?
Well, I'm very interested in this kind of topic because we are developing the proximity chart for the municipality. And one of the things that we are working on is the sort of mobility patterns that we can find on the public space. And another thing is how to change the culture of the car and to put people feel that walk is a nice thing to do. It's great to do, and I want to walk instead of going in a car to a place that I can walk to. So this kind of research, they are trying to deal with this topic about walkability and how people go through the spaces in the streets, etc. One question I have for you is if you ever thought about introducing another layer that it's the functions of the streets, if there is commerce, services, whatever, what kind of attractors a street can have in order to, in a way to shape the movement and the relations between those attractors, if it is all commerce or all services or everything is about housing or whatever. So if that layer is on your horizon to increase the density of the research or not, and if it is, how you imagine you can do that, because I'm really curious about it.
Thank you very much for the questions. It's really interesting. I think the first question is too difficult or challenging. It's not difficult, it's challenging. How to change the behavior of people. As I can see from different researchers and different applications, the most things that works well is by incentives. You cannot just persuade them, the walk is better. Okay, give me something in response to this, and I'm going to value it. Okay, I'm going to walk. If you're not, try to persuade, okay, do this because it's better for your health, better for, most people are not going to listen. But if you're going to say, okay, if you're not going to use your car, I'm going to decrease your taxes. Okay, let's try it. So it's always about incentives, or try to trade. Okay, don't do this, which is harm the city, harm the people, but I'm going to do this for you, and don't do this action. People will listen. This is how I feel it, because it's trying to persuade them without giving them into return or long promising return. They're not going to do it. They need something immediately, at least to see, okay, if I'm going to change my behavior, yes, I'm going to gain something immediately. And then there is something on the long run. Okay, I'm going to grasp it at me or my children or my grandchildren. So I think it's about incentives and how to persuade people to accept these incentives, that this is for their benefit, not the benefit of the general. They need to feel that there's an individual benefit. At least they're going to gain something. This is the first point. I don't know if it's something acceptable or not, but this is my feeling. I mean, people need to understand that they were going to gain something. The second point, yes, we wish to do it, but in order to do or try to have the model understand whether this place is a commercial part or this place is just street vendor or this place, or I mean, understanding things, we need to train our own model, because general models is too generic and they might not understand or capture the local culture of the place. Because sometimes, I mean, the shape of a church in general, that's the shape of church, but you have different churches, different sizes and for different issues. Which one of them, they might be trained on certain type of churches, not the others. So not going to detect them correctly, like mosques, like anything else we're going to deal with. So that's why I think if you're going to implement it, you need to have your own local trained model in order to work well with your specific case. I don't know if I've answered the questions, and forgive me for the first questions, just a personal opinion.
No more questions? I guess we have to go to lunch.